Thank you for joining today's Virtual Technology Summit. This is an introduction to database as a service on the Oracle Public Cloud, hosted by me, Erik Benner. The session will be starting shortly. The following is Oracle's Safe Harbor Statement. The general intention here is this is an outline of their general product direction, and it's only intended for informational purposes, and you may not be incorporating any legal contract. Please read the details of the Safe Harbor Statement, and we'll start in a second. Hello, my name is Erik Benner, and I'm an Oracle ACE and an enterprise architect for Mythics, an Oracle Platinum partner. Been working with Oracle technologies since the 90s. In fact, been working with Oracle Database since 94 when I went to Oracle 7. Actually did it in order to save money as I was using Informix prior to this, and Oracle offered more value for the dollar. I'm also very involved with the different user groups, and if you're interested in more about some of these Oracle technologies, please take a look at the IOUG, Independent Oracle Users Group, CloudSig. It's very active and specializing in cloud technologies. I'm also active in other SIGs around Enterprise Manager and Solaris, both in IOUG and OEUG. I'm a co-author on the book on the Oracle Database Appliance, and also the co-author on an upcoming book on Oracle VM that should be out by the end of the year. Also blog actively, both at talesfromthedatacenter.com and mythics.com/blog, and you can follow me at Twitter at @Erik_Benner. We're going to talk today is a little bit about the cloud. First, we're going to go through some use case of how you might look at using the cloud, and then we'll get into some of the basic features and functionalities and administrative requirements of the cloud. We're first starting off in a data center, and we have an older server here. It's been used to support an EBS upgrade or EBS project, and right now our IT leader has realized that this is an outdated system and that she needs something a little bit more powerful in order to support a new e-business upgrade project. Her first thought is to reach out to the sales guy, but she's afraid that the sales guy is immediately going to say you have to buy cloud, and that's going to solve the problem. And this is a very understandable concern, but we have to realize is that the cloud actually works in your environment. The first conception is that it's not the same database, but the cloud runs the same database you run with your on-premise, also known as on-prem in cloud terminology, system. It's the same database that you would use with an on-prem solution. It really makes your role as a DBA very similar. It's also easier to run than an on-prem database. We'll go through the provisioning process here in a little bit, and you'll see how easy it is to build an entire virtual machine with a cloud-based database and actually configure the database, and then we'll go through and do some backups on it. And the nice thing with the Oracle Public Cloud is today I can run database 12.1 or 11.204. So if you had older applications that you haven't yet taken advantage of the upgraded capabilities of database 12, you can still keep it on 11.204. So we're back in the data center with our old application development system. And our IT leader here says that you have to find a solution, and she's going to her head architect, her head DBA. And of course your DBA is going to do what you're going to think. Hey, we looked at a solution, I have an old server. Have you looked at the Oracle Cloud? And there's reasons for that. One thing is that OPC, also known as the Oracle Public Cloud, is a secure environment. It actually starts off from when you do the first installation in a secured configuration with a lot of features, a lot of access actually reduced, again, to provide additional security. But on top of that, you still have full control on the system. You still have root access, you still have sysdba access. Your access to manage the system is really no different than an on-premise solution. And best of all, patching in the environment becomes much easier. And what will happen on patching is when a new patch comes out, you get a notification that your system has to be upgraded, and then you can select whether or not you want to upgrade it now or later. It's really that simple to patch. No more messing with patch and checking out dependencies and validating the patch. It can happen automatically with a couple button clicks. So we're back in the data center here and going through our storyline here. And our admins, our DBA saying, hey, we're going to look at it. And the next thought that your leadership is going to have is, well, the cloud has issues. We've all heard horror stories where these big outages from cloud providers and people have been hacked from their cloud provider. But what you have to look is that cloud's not a commodity service. What I've been saying for years is what you pick matters in the data center. One size shopping doesn't work in a data center. Just because it worked for your friend doesn't mean it works for you. When you buy IT technology, it's kind of like buying clothes. One size fits all doesn't work. And the same thing works with your cloud services. And there's differences there between Oracle's cloud, which is why we use it, as well as the other public cloud providers. First of all, security. Oracle Public Cloud as a DBA automatically gives me more security day one. I actually have firewalls that are installed, configured, and locked access to the database, and I, as the admin, the DBA, have to enable it. There's some other neat little features that you don't think about. One we always worry about, especially with my client base and users, is encryption. And a neat thing is encryption in the public cloud is included. All your data files can be automatically, you can encrypt them all you want using transparent data encryption. All your backups can be encrypted. And communication between your application servers and the cloud database servers can be encrypted as well. You get more security out of it. You also gain agility, and this is something a lot of people overlook. With an on-prem solution, I have a certain amount of hardware, and if I need to add capacity to it, I have to go and add physical capacity to the servers. I then have to go add licenses to the servers. Sometimes, if I need to reduce capacity, I can't turn back physical capacity to my server, and I can't turn licenses back to Oracle and say, hey, I'm done with this license, give me a refund. That doesn't work. But in a cloud environment, you now have that agility to do that. You can scale up and you can scale down, and your bill reflects that. The resources you consume reflect that. And it gives you a lot of flexibility you might not have in other environments. And licensing actually is a really neat thing with Oracle Public Cloud for database as a service. Yes, there are other companies that offer a database service, but what they don't come with is all the licensing packs that you get with the Oracle Public Cloud. There's a lot of packs that I'm showing users with. Partitioning, advanced compression are two that come to mind. Things like lifecycle management pack or geospatial and graph. There's a lot of these packs you might not be familiar with. A lot of them actually can help your life as a DBA. And with the Oracle Public Cloud, depending on your tier, the more popular ones are included in the tiers, and then as you move up in the tiers, some of the more rare ones, such as Golden Gate, can be included, or Rack database can actually be included in the licensing, and you really don't pay that much of a premium for it. And what's cool there are the licensing, since you now have all these packs, even on the basic enterprise edition, that you might not have had with your on-prem solution. You now find that you can start taking advantage of these technologies. You can use things like automatic data optimization for your 12C databases to automatically do compression levels at different parts of your database and have it automatically compress or decompress data depending on how it's used. And these are things you might not own prior to moving to the public cloud. Another thing with the Oracle solution, and we used it at our work for our document management system, our document management workflow management system, is that you get the integration to it. That Oracle has software as a service, the infrastructure, the platform, the database, all these components are Oracle. And when you're using this on the Oracle Public Cloud, you can actually mix and match it. And we do that for our own workflow application. We use business process management, we use Oracle Docs, and we use some database and platform services to glue it all together. That's something you don't get with a lot of other cloud providers. Some cloud providers are really good about giving you a virtual machine, which is infrastructure as a service, and they might give you somewhat of a database on it. There's other cloud providers that are really good about giving you a software as a service solution, but they give you nothing else in the environment other than this software as a service solution. And they don't give you the integration capabilities that you get with having Java and infrastructure, VMs, and database, and be able to mix them together. The Oracle solution is neat that it gives you all these functionalities, all these features, and you can use those in your public cloud offering, in your service that you subscribe to. And you can start integrating these different services and putting them together. It's kind of like baking, where it's great if you get the basic components. You can buy your sugar sitting at one location, and you can have your flour at another location, you have your eggs somewhere else, and that's kind of cool. But when you start mixing them all together, you can make something really unique, like a cake is an example that everyone likes. And you don't have to go to 3 different stores. You don't have to use different kitchens. It's all in one location. Lets you put it together a lot faster and honestly a lot cheaper. So we're back in our data center with our old server. And we've decided to go to the Oracle Cloud for some of these advantages. And the next question is, great, I've bought it. We've gone to the sales rep. We've bought it. What do we do next? But one neat thing is when you go buy it, what you realize is the license saving can actually pay for the service because of all the packs that come with that offering for the database. All those database options that you don't normally get. When you add all those up, it becomes a better value. It becomes a money saving for you to buy it that way than to go buy all the packs individually and then have to pay them off in 3 years. And that those savings alone can actually help pay for the cloud service. When you configure the cloud now that you've bought it, the initial configuration is actually very easy to do, and we'll run through it. The first thing is the public cloud is all based off of SSH keys. We're going to prepare and use these SSH keys in order to generate how we access the system in a secure manner. We'll then create some user IDs for the system. Then we'll be able to log in the system and actually create a database, which is a very straightforward process. And here we're going to do a quick little demo on it. We'll actually go through how we log into the system, and we'll go ahead and create a little database. So now I've switched over to my web browser. In this case, I'm using Chrome, and we're going to go ahead and log into the Oracle Public Cloud. So I'm going to go to cloud.oracle.com. And here I have a couple options. One, I can look at the material for sales, application platform, which a database falls under, infrastructures, virtual machines, and storage. And I can look here and see what offerings are available, what list prices are, etc. What's more important though is I'm going to click on sign in here. This will give me access to the cloud. The next thing is I have the page of what I want to do. I can get with some of the more advanced things, order management, Fusion notifications, but here I'm going to log into my cloud account. One thing neat with Oracle is they have multiple locations, multiple data centers. My cloud account with my what's called identity domain is tied to a specific data center location. And you have data centers in the United States, Asia Pacific, Canada, EMA, Latin America, and 2 special ones. These are public service clouds for the US and EMA. Those are only for public service agencies, like state and local agencies as an example here in the US. And they have a special cloud service available to them. It has some special security to meet their requirements. In this case, my system's in US Commercial 2, so I'm going to select US Commercial 2. Then I'm going to go to My Services. This will then prompt me for my login with my identity domain. This is my master account for my cloud access. It gives me full access to everything in the cloud. Here on my identity domain is Benner ACE, so I'm going to log in. And now it wants to know the username, so I'll put in my username here in a second. And then I also want to put in my password. And we'll pause this here simply because I don't need everyone seeing my password. Sorry guys. So now you see I've been able to log in using my ID and password in the cloud. Now I get my dashboard that shows all the services I have accessible to me. I have the Oracle Storage Cloud. This is where I create space for my databases, space for my backups. I have my Compute Cloud. This allows me to generate virtual machines. The neat thing with Compute Cloud is it's not just Oracle operating systems. Oracle lets me out of the box from Oracle create virtual machines running Oracle Linux, but I can also create machines using Solaris, and I can create machines using Windows even, 2012, as well as variations of Ubuntu Unix, and a couple special virtual machines for some of the other extra services like VPN. I also have access to business intelligence in the cloud, BIX, which if you're looking at a BI solution for a small number of users, it's an excellent way of looking at BI. I have my database backup service that allows me to back up my databases to the cloud. And then I have my database cloud service, which we're going to play with here. And you can get an idea of what I've used for services. So here I'm going to click on Database Cloud Service. This will show my summary in here. They'll show what data center I'm in. This is US Commercial 2, the current version we're on in the system. I have an active account. What's also important to understand is the REST endpoint, and we're not doing it right now, but there's a whole RESTful call that you can use against all your services. Actually automate everything we're going to do through these RESTful calls. This enables you to automate accounts into the system and give you additional access down the road. We can also see I'm tied to Mythics, who's my employer, and that's tied to my Oracle account. And then my service start and stop dates. Here I have when my service expires, as well as some other information. We're going to go ahead and go into the service console. This will let me manage my databases in the environment. And I'm in a hotel room doing this, so I apologize for my internet speed tonight. So here I have one service up and running. This is a BICS database I'm using for another little project right now. But I also have what services are consumed. I'm using one BICS database, 15 gig of memory. I'm using a little bit of storage on it and one public IP address. I want to go ahead and create a new database. So we'll go ahead and create service. And this will send me through a series of prompts I'll use in order to create my databases in the cloud. So the first thing is the type of cloud service. I have two choices. I can use the database cloud service, which is a pre-installed virtual machine with a database installed, and Oracle will actually use the cloud interface to create your databases, and it's available so I can do my database creation, my patching, my recovery. The other option I have is a virtual image that has database pre-installed, but there's no additional cloud tooling. If I want to patch, I have to use OPatch. If I want to create a database, I actually have to bring up a GUI and use like DBCA to it. So for this instance, we're going to head and use the normal cloud service. We could also pick the billing, hourly or monthly. I'm going to use the monthly billing metric. The next thing is really cool is you get to pick the version of database. I say this is really cool because some cloud providers are now saying the only database version you get is the one version of the database they offer. They only offer like 12C and Standard Edition. Oracle gives me my choice of running 11.204 or 12C Release 1. And having 11.204 is nice, especially if you're running like older versions of eBusiness. You can actually bring those databases online on 11.204 if you haven't upgraded to 12 yet. For this example, we're of course going to stick with 12. Now I can pick the version, and this is a little different than you're used to. If you're a normal environment, you see your basic choices, Standard Edition or Enterprise Edition. But with Cloud, I get some additional options for Enterprise. I have high performance and extreme performance, and the main difference between these databases is the licensing. So if I look at Enterprise Edition, going back to my page for the cloud service page, and I look at the overview, and I'll see the services that are available. Exadata is an option, database is a service, and I get the different offerings. But if I go to pricing, we'll see I have Standard Edition, and again you'll see the high performance and extreme performance. The reason I brought you to this page though is to see something really cool, the licensing. So Enterprise Edition, Standard Enterprise Edition. But if I do high performance on Enterprise Edition, what you see here highlighted are a whole bunch of license packs that are included. I get multi-tenant out of the box. I get partitioning, real application testing, advanced compression, advanced security, label security, database vault, OLAP, advanced analytics, spatial and graph, diagram tuning packs, lifecycle pack, it goes on, data masking and subsetting, and cloud management pack. So I get all these packs in the system. These are things I wouldn't normally get with just a standard database, and they add a lot of value for cost savings because these are packs that I might actually use. I want better security, so I might actually use Database Vault now that I have it available. Or I might use label security to have more control over who sees the data. Or I might start using data masking in my environment where I wouldn't have used it before. I could then go to the extreme performance version, which takes it up an additional notch, and I add in technologies like in-memory database. If you're doing any type of analytics, any type of data warehouse, take a look at in-memory database. It's like pouring liquid oxygen into your engine when it comes to data warehouse applications. I also get rack databases, so I can easily build rack databases in the system for availability. And I now get Active Data Guard. If you're not familiar with that, this is your Data Guard target, but your Data Guard target is now available in read-only mode. And that really helps for doing like data warehouse analytics against your standby database. And these are things that are different. So you need to understand with high performance and extreme performance, you're getting all these extra packs you wouldn't normally get. So in this example, we're going to go ahead and go extreme performance just for fun. And you can see here we also get the details, which the link I showed earlier. So we're just going to go on extreme performance. The next thing we're going to get is the details for this service. So we're going to call the service VTS, and we're going to call this the VTS demo database. And now we're going to figure the shape, and the shape is a combination of CPU and memory. What you have to look at is they call OCPUs. And when you look at the shape, you're going to have different tiers, OC3, 4, 5, 6, 7, etc. And that's how many virtual CPUs are on the database. On top of that, you have two different memory sizes. You have normal memory, which gives me 7.5 gig per CPU. And then we have the high memory configuration that gives me 15 gig of CPU. So in this example, I have limited resource, so I'm going to pick one database with one OCPU, but I'm going to go ahead and pick the high CPU configuration for the database. Now I can pick the time zone. I'm going to run it in universal time. We're going to take a quick little side trip here and just go over a little bit about SSH. One of the most common problems people have is managing SSH keys. A lot of DBAs are not just used to using SSH keys. So we're going to go over here real quick, just a little bit about the history of SSH and a little bit about how keys work. People go, what is SSH? Because they think it's a command often on the machine. You're on a Mac, you type in SSH and it's how you access a remote machine. But it actually stands for the secure shell. And it's really a protocol. It's not a product. It's not a program. It's a protocol for encrypting communication. And it's not just communication for command line access. The same protocol also allows me to do file transfers. In the Oracle Public Cloud, all my access to the system by default is going to be SSH. I'm going to SSH into my VM that runs my database. Once I SSH, I can use that same SSH connection to actually transfer files as well. And its whole purpose of SSH is to encrypt the data between the client and the server. And that's really what it does a really good job doing it. It's built into all your modern Linux and Unix distributions, and that includes your Apple Macs that actually run BSD, which is a Unix flavor of Unix. And it also has several programs available for other operating systems like Windows. It also includes ANC, which is also based off of FreeBSD if you're using a lot of BSD. Again, it's ported to many operating systems, Windows, mainframe, Android. There's one which is really Linux, but it has it there. Even on iOS, I can SSH from my iPad. The most common for Windows admins that you use is called PuTTY. It's the most common SSH client for Windows. I use PuTTY myself for it. But also there's clients available for iOS. You can get it SSH for Android if you don't have a rooted device. There's just a ton of clients out there. Pick the one you like the most. It was built as a replacement for Telnet and RLogin and RSH and RCP and FTP. These are all ways of providing command line access to a system, and they're all ways of transferring files, but they're all unencrypted. There's no encryption in there. So if somebody uses an old style Telnet to access a server, and somebody's able to watch the network, you can actually see everything that person types and everything they see. With an SSH connection, it's all gibbly, garbly gook, and you really can't understand what's being typed with a network sniffer. A little bit on the history, because SSH is one of these technologies that just exploded even as fast as the internet did. Back in 1995, a researcher in Helsinki came up with his first protocol called SSH version 1. And his idea was to replace all these unsecure, unencrypted protocols that were used for file transfer and shell access. By 2000, within 5 years, there were already over 2 million users of SSH, and it's exploded since then. There's an odd variant, 1.99, that you see every now and then. In 2006, they came out with this new version of SSH that was developed, or actually 2000. In 2006, they came up with this other version called version 1.99. It's really there for backwards compatibility with SSH, and you'll rarely see it after that. What you really see in 99 is OpenSSH got a little old. They came out with a new version called OpenSSH 2, and that came out, and that was released, and that's generally what most of us are using now, was the SSH 2 release. Again, that's in 2006 on here. It's incompatible with version 1. So SSH2, if you're talking an SSH version 1 server, they're not going to work, but it's pretty rare now with any modern system to see any SSH 1 or 1.99. But be aware, occasionally you come across old servers, you can't connect to it, because they're running version 1 of the protocol. There's some terms there, if you use a lot of SSH, you'll hear. SSH, generally in uppercase, is a generic term for the protocols in the command. When you see SSH lowercase, that's generally is a verb used. I'm going to SSH to this server. It's also the common name for a client on a Unix or Linux machine. SSHD is the server daemon. That's what you connect to with SSH. You have SSH1, SSH2 are just simply versions of the protocol. Again, we don't see one very often. You have OpenSSH, which came out of the OpenBSD team, and that's one of the most common Unix SSHs you see for Linux systems and BSD systems. Sun Microsystems also developed their own version of SSH. It behaves a little differently than OpenSSH, but what's interesting is it's commercially generated, and it actually tends to have a history, I believe personally, it's been more secure. We had a lot of things going on with SSL over the years, and the Sun system was never, SSH was never affected by it. The important thing is to think about SSH though is that it's all encrypted, and the encryption happens before any other data is passed. So if I'm taking my client machine and I'm going to SSH to a remote system, the first thing that happens is the two servers encrypt the communication link between the client and the server. Then you authenticate the session, and then you can either use it for command line access, you can use it for copying files. This is how we normally use SSH, and we normally authenticate by putting in an ID and a password. What changes with an SSH key is the key is used instead of an ID and password. And there's two aspects to the key. There's the private key, and this is the file that you have that you don't give to anyone else. You use your own private key, no one else uses it. You then have a public key. This is the file that you give to people to authenticate who you are. Anyone that has a public key will trust you if you have that private key in the system. You also have two different ways of using the encryption, RSA, DSA. There's differences between the two. Most everyone uses RSA now. On a Unix machine, you can use a command called SSH Key that'll generate the command. On a Windows machine, I could use PuttyGen, and we'll use that here as part of the example. What happens with that key is I'm going to have a red key and a green key. My red key is my private, my green is the public. So the first step is I generate and store the keys. I then do my SSH session, and everything is encrypted, but I haven't authenticated yet. What will happen then is my PC will send, the private key will be sent. The server has the public key, and it's going to validate using that public key that public key matches the private key, and there's some cryptology that happens in there. Once that cryptology syncs up and matches and authenticates and validates, you'll then go into a normal session and authenticate. What's important there, since it's not a password, you really can't guess the SSH key. They're very long, complicated strings of numbers, and you just can't guess the key. Where the normal password, I can easily guess a key. Hey, my key is let me in. Or my key is, wibbly wobbly, timey wimey. It can even be a long phrase. The important thing is you can guess that. You can tell somebody it. With a private key, it's just a lot of gobbledygook text. You could probably tell somebody what it is, key by key by key, but they're really not going to be able to guess it. You can actually transfer a key, copy it to a file, and send it to somebody, and then they have access to the key. That's generally how they're moved. So that's our basic piece there. With key, on a Unix machine, you'll have a file called authorized keys. Here's an RSA key, and you can actually see the key has a lot of gobbledygook in it. It's all text and numbers, characters, and that's what a raw key itself will look like. Here in a second, when we go back to our session here where I'm creating the key, we'll use PuttyGen, and we'll generate a new key for the file. So now through the video editing wonders, we'll go back to our earlier session. And now I have the SSH public key I can use, and I'm going to have a public key that I'll use to authenticate to the system. And here on the public key, I can choose a file that I've saved it before, or I can go ahead and paste it in. Now, a neat thing under Windows, if I already have it, I can use SSH Keygen. PuttyGen. This will let me generate a new SSH key. And this is for security. And this is a normal SSH we're used to. We just log in with ID and password. Keys are a lot more secure. They allow me to authenticate to the database with a key. That way it's what I have, it's not just what I know. It gives me a lot more security in how I authenticate for the database. So here we're going to go generate a key pair. So we'll click on generate. We just randomly move our mouse around, makes it real easily. You can stop for a little bit, move it around a little bit more. This is all the randomness. Now we've generated a new RSA key type. We put a comment. We can actually put a passphrase in it. And that passphrase means every time you use the key, you have to type in the passphrase. We're just going to go ahead and highlight the whole key here. Copy it, copy it. We're going to go paste it in the key value. It's plain text. And I'll save the key. Now, important thing is a key has two pieces. It's a public key and a private key. And while I could build the database just using the public key and pasting it in there, since I haven't saved that key pair combination, I might have problems down the road trying to actually use the key. So what we're going to go ahead and do is we're going to save the public key. So I'm going to go save it to Windows, and I'm going to call this VTS pub key. And I'm going to go ahead and save the private key. We're going to save it without a passphrase for simplicity. We're going to call this VTS private key. Having that private key means down the road, if we need to authenticate using the key, we can actually use that private key to actually authenticate against the system to log into it. The next piece we're going to look at is our database configuration, how much storage. Here I'm going to keep it a relatively small database. We'll make it 25 gig. We now type in the administrative password. Oracle, being again secure, has some policies and enforces a special password. So we're going to put in our special password. We'll put it again. We'll put in the second special password again. And make sure they're the same, and they're not the same. It's smart. So we'll try it again. And now they're the same. Now we have the database SID name, and we're going to go ahead and call this VTS, and we're going to give it a pluggable database. Since we're using multi-tenant, we're going to give that pluggable database. We'll just call it PDB1 for the example. And then we can pick our character sets. Again, these are all things we're used to doing. As a DBA using DBCA, it's just done a little bit differently. So we'll just keep to the default Unicode. Now, based off the size, it's going to calculate, it's going to estimate that if I have a 25 gig database, it's going to estimate I'm going to use about 140 gig a month. This is a rough estimation here on this number. Don't get hung up on that, because the reality is it's going to use how your database would normally consume storage. We can also automatically, just by clicking this rack button, it'll automatically create a 2-node rack cluster for us. It's even easier to install rack this way than doing a rack attack. We could also, if we have a primary database, we can set up a standby with DataGuard. We can also enable Golden Gate by default. We can also include the special demo PDBs. We're not going to mess with any of those options. The last thing is we're going to talk about is storage. For now, your options are you can choose both cloud storage and local storage in your VM, or cloud storage only, or none. For now, we're going to say none, and we'll come back later and configure the cloud storage. We'll click on Next. So now that we've gone ahead and created it, we'll get a quick summary of what is in the cloud offering page here. Again, we've created no backups. We'll do that later. Gives us our frequency or summary of what the database is. And now we'll go ahead and click Create. The system will now go ahead and provision the storage for the service. And I'll go ahead and provision the database. This will take a little bit, so we're going to put this on pause and come back and check it here in a couple minutes. What you'll see here, though, is that we see the demo creation is in progress on the page. And we'll see that the status is in progress, and we'll see when it was submitted, and then we'll wait a couple minutes and we'll check on it. Thanks. Okay, now through the wonders of internet editing, we've gone ahead and created the instance, and you'll see now we have the instance listed here. It's Enterprise Extreme Edition. We can get some more information about the instance on here by expanding it. And this will give us some more details about the instance we just created. It has one node CPU, memory and storage. More importantly, we get the IP address of the instance. This is on 129.144.14.75. So now we know the IP address to SSH into it. So that's what we're going to do next. So I'm going to go ahead and close my other SSHs that I had created here. In my PuTTY session and a little bit of email. So now we're going to SSH to it to make life a little simpler. We're going to copy the IP address here, put it in the SSH window. Now we'll go ahead and SSH in. We'll log in as the Oracle user. The first time it'll go and log in, and now because of the keys we have it set up. Now I did cheat a little bit. There's a utility here called PuTTY Agent that I have running. And you can see I get to the toolbar, you see the little agent, I go to view keys, and this is the SSH key I previously created. We can go to add key, and this is the key I brought in here, which is VTS private key. I can add in other keys if I want, and it's a key manager. That way it uses it. If I remove the key from the system and close it, and go ahead and close this window. And now if I start off another SSH, pasting it in there, it'll go open up and we'll put in Oracle, and now give us an error message because we don't have that public key there. We can go in our command bar, right click, go to add key, and I had that saved here in the cloud attack, which is a cloud SIG hands-on lab that goes through all this. And here's the VTS private key. Go on the PuTTY session, we can simply restart it, log in as Oracle. We've loaded the key authenticates, we're into the box. And now at this point we're in as Oracle. I can go ahead and set my Aura ENV to VTS, which I think it already set to, and now I'm the VTS. I can log in as SQL Plus. And I'm connected just like I would with an on-prem database. Same commands, same basic usage. Here though, you'll see we have a lot more options than you normally have enabled because we're entitled to the licensing. So I'll go ahead and exit out of here. Go back to the web interface, so we'll see the name. What's also interesting is I mentioned agility, and we can very quickly make changes to the node. So I can start it and stop it. I can restart the node. I can also scale up and down. By scaling up and down, it allows me to add or remove OCPUs, which is a combination of cores and memory, from the node dynamically while it's running. So if I click on scale up, I can take it from memory shape 1. I can change it to any of these parameters, assuming my database resources at my subscription can handle that node. Obviously, my account here I use doesn't have 16 OCPUs. I can't grow it that large. I can also add additional storage to the database by creating a new storage volume or extending an existing volume that I have. This allows me to dynamically change storage. So we're in here, we have the database created, we're up and running, we're ready to go. To connect to the database, port 1521 is open, but only if through the SSH. With SSH, I can create an SSH tunnel and connect to the database that way through an SSH tunnel to port 1521. And that's what I would recommend. That way you have better security, you have encryption, you have some authentication with the SSH keys. It just gives you a better environment, a more secure environment to work with. So the next thing we're going to do here in a minute is go back and we're going to talk a little bit about the next stage of the configuration. So now we've done our basic configuration of the system. So now we're going to talk about backing it up. There's a couple steps we have to do the backup. The first thing is we're going to download the Oracle Public Cloud client. Here's the current URL for the client. And we'll take that jar file and we'll actually upload that file to the database VM that we created. We're going to unzip the file so we can use the jar file. And then the next step we're going to do is we're going to create an install script. Here's a sample script here. What you're going to have in this script is you're going to have the name of the install file, which is going to be the OPC jar file that we installed. Service name, I'm going to use the storage, which is the default storage location in the system. Identity domain is your identity domain. Here I'm going to use Benner ACE, which is my identity domain. The next thing is you set your Oracle Public Cloud login and password. I'm not going to share that information. So here I've just parameterized it with login and password. You'll need to change that to your login and your password ID in the system. The next configuration is the wallet directory. This is where some of our encryption wallet keys are going to go. We'll need those for TDE. We'll need those for authentication between the backup software and the public cloud, as well as the library. Here, by default, this software will install in the Oracle Home Lib. Some instances you might install a different directory. This is basically the library for the RBAC driver for the public cloud backup system. So don't forget, even if you take this and copy and paste from this sample here, you need to update your login and password, otherwise it will not work. You'll then want to save this script to a script. I used an quick install script. You want to chmod plus x the script. That'll give it executable parameters. Then you simply run the script. That'll take a couple minutes. It'll actually download the latest software from Oracle, install it in the library, make sure your wallet's set up for ID and password for authentication, store that for the public cloud. One of the things is if you're using this, you might want to go back on a reoccurring basis and every now and then rerun this same script. And the reason is every time you run it, it'll connect to the cloud, get the latest software for the backup service, and install that in the database instance. So that's something you might want to look at every now and then and think of as a patching life cycle for it. Once that's installed, we're going to go ahead and edit the sqlnet.ora file. We're going to add these commands. We're going to basically tell it where the encryption wallet is. In this case, an home Oracle OPC wallet. One thing here with the Oracle backup service, you have to encrypt or else. You cannot back up to the backup service unless your backups are fully encrypted. You have two ways of doing it. You can use password-based encryption as a single-use password, or you can use TDE. Here I'm going to do a very simple transparent data encryption configuration for the system. You can get a lot more sophisticated. That is a whole different discussion we simply don't have time to do. But you have to understand it enforces the encryption. If you're not encrypted, you cannot back up with the service. Security is first in this environment. For the TDE encryption, we're going to keep it really simple here. We're just going to go ahead and we're going to enter an encryption key called password. And we'll create a very, very simple wallet for that use. Anytime the database is started for this example, you're going to have to go ahead and set the wallet opened up by the password. We're just keeping it simple. We're not going to set the wallet to automatically open up. Again, that's time for a whole different conversation. So the next thing we're doing is we're going to go ahead and do this on the demo system and set up the backups. You'll see how easy it is to run all these commands. We'll also show a little bit on how I copy files with WinSCP on Windows machines using that encrypted key pair that we just made. We'll go ahead and make the commands, run the installer, do the basic TDE configuration, and at that point you can run your RMAN backups just like you normally would. Now through the wonders of editing, we'll switch over to the other screen. Okay, so now we're going to go ahead and we're going to copy the file over that we've already downloaded. I'm going to go ahead and copy the IP address so I don't have to type it in. I'll bring up WinSCP, which is my preferred method. I'm going to go ahead and put in the IP address. I'm going to type in the user Oracle. And now I'm going to use that SSH key file again. We're not going to use a password. So I'm going to go select the key file, which is my VTS key file, and this is what I'm going to authenticate with WinSCP. WinSCP is simply a Windows program that lets you use the SCP protocol out of SSH to copy files. So we've set our key, we put our system, our Oracle, we're going to connect over the internet, it's going to authenticate, use the key to authenticate. Now we're connected into the system. I'm going to go ahead and get into my cloud directory where I happen to have my OPN installer, and we can just hit F5 and we'll copy it over. It already exists, so I'm going to tell it to go ahead and overwrite it, and the installer will go ahead and overwrite the file. We're now going to go into that directory. I've already SSH'd into it, and now we have the I'll go ahead and unzip it. And here's the installer.zip. So we're going to unzip the installer here. Yes, we're going to overwrite our file that already exists. This will undo the installer. We're going to go ahead and rewrite the README, which are some basic directions. Now we're going to go ahead and we're going to create the file. Now what I've already done is I have a sample file I've created, and this is what it's going to look like in the sample file. Here, just like I showed in the PowerPoint, we're going to have our storage, which by default is storage. Later on, you might want to have your database. You can create a new service, maybe call it an archive as a new container, and you could have your backups go there. If we're going to go ahead and use my identity domain, Benner ACE, I will replace the login with my real login. I'll replace my password with my real password. I've gone ahead and created the home Oracle OPC wallet directory, and that's the directory I'm putting the wallet in, and I'm going to use my library directory for the Oracle home lib. And now I'm going to go ahead and chmod the file, so I'm going to make it executable. And now I'm going to run the backup file. This will go ahead and connect to it. Here's the latest build. It'll validate my credentials to the public cloud. It'll then download the latest libraries from the cloud and install those into the library directory. It'll also get a wallet for the keys, creating a separate set of keys and putting that in the wallet directory. So now I have that saved. So my RMAN user doesn't have to have the ID and password for my cloud account. RMAN will use the stored wallet for that. You can see this part of the process is pretty straightforward. Doesn't take that long to do. So the next thing we're going to do is edit the SQLnet as preparation for setting up the backup. And after that, we'll follow the steps to do a simple TDE configuration. And then we're about done with setting up some basic backups. So now we're going to get ready to configure our RMAN to use the public cloud. It's actually pretty straightforward. All we have to do is set our device channel to point to the drivers for the cloud. The first thing we're going to do is we're going to look in our Oracle Home lib directory. We're going to grep for OPC, and we'll see we have an OPC 12 and an OPC objects. These are the shared libraries for OPC. We're going to actually use RMAN to use libopc.so for it. We're also going to look in Oracle Home, and we're going to look in the DBaaS directory. And in DBaaS, we're going to see an OPC vts.ora. This is actually a configuration file that's installed with the cloud. And we look at it, it'll tell us the directory for the storage container. We said storage earlier, it automatically appends the Benner ACE, and this basically tells the location for this channel against the container in the public cloud. Okay, so now that we've done this, we're going to go check our wallet location in the SQL plus file, SQLnet.ora file actually. Being that this is a cloud configuration, a lot of automation was already done. Here it automatically created the wallet location in the system. It actually set a wallet password already. That password is the same password we use for sysdba. When you're setting up cloud backup and you're not doing this on an Oracle public cloud, it's an on-prem cloud, you're going to have to manually add this encryption wallet location with the wallet file identified. We can then log into the database as SQL Plus, and we can go ahead and set our encryption key identified by our install password. You'll see it'll let me alter the system. That's because the password is already set. So the next thing we're going to do is we're going to connect in with RMAN, and we're going to configure RMAN for the backups. So now we're going to configure RMAN. So we're going to log into RMAN, we're going to connect to root. So I type in root, right? And now we're going to go ahead and configure the channel. I've gone ahead and typed all this in advance, so I have all the paths correct. But you can see here, I'm setting my library with the libopc.so, which is the library for the public cloud, and I have the configuration file set. So we're going to go ahead and run that in there. And now our RMAN is configured for our catalog correctly. And at this point, RMAN is now pointed to the cloud. We can run a backup like we would in any normal time for the database. We're now backing up to the cloud. Congratulations. So now that we've connected to the cloud, we can just run a normal backup database with RMAN, and we'll go ahead and it'll back up to the cloud. I don't think anyone wants to sit through a 20-minute backup, so we'll continue with the session here. So that should actually, come to think of it, about wrap it up. We've come to the point where our data center has been able to provision a database in the public cloud. They've been able to configure it for backing up to the public cloud. And now we've actually been able to remove an old server from the environment and save some money in the process. It's actually pretty easy, and now it's time for you to give it a try, and you actually can. If you go to cloud.oracle.com with your browser, you can set up yourself, sign up for a free trial. And when you get to the cloud login here, you'll see the same login we used to log in, and just click on the free trial button there. And then you'll be able to sign up for a free trial for the cloud services. And with that being said, I appreciate everyone's time. And we're going to open up now for a couple minutes of Q&A. If you have any questions, please feel free to type them out and let us know. Thank you.